Okay, ladies and gents, how exciting is this? We've now got our first steps into the C3 world, and we're going to be doing it via the flipped classroom method. So, what I need you to do is, in your notes book, I need you to take notes on this first chapter, the title of which is Algebraic Fractions. Now, this should be quite a quick video, to be honest, because I think the work is very sort of doable. And so we're going to have a look at the basics, and what we're going to do, we're also going to try and compare what you've also done in the past in terms of fractions and see how you compare it to algebraic fractions. So the first one, if we have a look, we've got to find the simplest forms of the fraction 16 over 20. So 16 over 20, what you would do is you would find something that goes into both of them. And obviously, you'd do this one in your head, but we could also say that 16 over 20 is the same as 4 times 4 over 4 times 5, and as long as we multiply the top and the bottom by 4, multiplying everything on the top by 4, and multiplying everything on the bottom by 4, then we can just cancel that out. So that goes down to 4/5. So if we use the same process for part B as we did for part A, what we can do is we can say that x plus 3 over 2x plus 6, we can actually rewrite that as x plus 3. There's no way we can simplify that, but we can have the bottom as 2 lots of, or 2 times, x plus 3. Now what we can do is we can cancel the top from the bottom. Now if we cancel the top and there's nothing left, we leave a 1 on the top. So that simplifies down to 1 over 2. Now let's have a look at part C. So C, we've got x plus 2 over 3x plus 8. What you've got to be careful is that you don't cancel out 2 from the bottom and 2 from the top, so that goes down to 1 over 4, because that doesn't work, because you don't have a 2 in this thing, you don't have a 2 in this thing, so you can't do that. So x plus 2 over 3x plus 8, you can only do that if you've got the same thing in everything. So there's not a single number other than number 1 that's in everything. There's not a single letter that's in everything. And we can't factorise the top and we can't factorise the bottom, so therefore that's as simple as we can make it. But what we've got to be familiar with is how to identify when something's as easy as it can be. Okay, so just make sure you got all the notes down for that one. Let's move on to something a little bit trickier. So some of these haven't come out as good a quality as I'd hoped. Let's say we've got half x plus 1 over a third x plus 2/3. Now, the thing that makes this fraction tricky is the fact that you've got fractions within fractions. Now, just like when you first learned about fractions, and you've got to give an equivalent fraction to 3 over 4, as long as you do the same to the top, so for instance, 6 over 8 is the same because you've times the top by 2 and you've times the bottom by 2. So, if you do the same to this as you do the same to the bottom, then you should be fine. So what we've got to do is we've got to multiply the top and the bottom by something, which is going to help us tidy it up. So if we have a look at the individual fractions on the top and the bottom, we can see that 2 and 3 both go into 6. So if we times the top by 6 and the bottom by 6, that should help us out. So half x times by 6 is going to be 3x. So that's 3x plus 6 on the top. And if we times the bottom by 6, we're going to get 2x plus 4. So there we go. But what we need to do now is we need to check to see whether or not we can break that down anymore. So we've dealt with the fractions part of it by timesing top and bottom by a common denominator. Now, I can see 3x plus 6, that can be factorised. So if we take the 3 outside, that goes to x plus 2. Then do the same for the bottom. We can factorise out the 2, again giving us x plus 2. Then what we can do is we can cancel out the top, cancel out the bottom, leaving us with 3 over 2. Now again, people might find this easy, but the important thing is to be thorough, because it's very easy to miss things and make mistakes. Unless we're really thorough, we're going to first of all drop marks, and also we're going to make it harder to do subsequent parts of the questions. This first chapter on simplifying fractions is all about trying to make it easy for ourselves a little bit later on, because it underpins everything. Okay, the next thing, we've got to simplify these expressions. So we've So let's have a look at the bottom. We can factorise that. X plus 1 plus 3. So that's nice and straightforward. Now, the thing that sets people apart from people that can do A-level maths successfully and people that can't is being able to spot things. So x squared plus 1, you need to be able to spot that's the difference of two squares. So that's going to be x plus 1 and x minus 1. And if you're at all unsure, if ever you've got something like, I don't know, 9y to the power of 4 minus 16a squared b to the power of 6. This is the difference of two squares because there is something that times by itself to make 9y to the power of 4, and that's going to be 3y squared. There's something that times by itself to make 16a squared b to the power of 6, which is 4a b to the power of 3. Then what you do is you have one of them as plus, and then one of them as minus. So going back to our question up here, we've factorised the top to get x plus 1, x minus 1, factorised the bottom to get x plus 1, x plus 3. We're then going to cancel out that and that, leaving us with x minus 1 over x plus 3. Okay, so now we're going to do, so that was part A, and this is part B. I would love it if in the comments box people could find out how I get my pen on default to this thickness, because whenever I change colour it goes back to being this thick here. So any ideas for that will be gratefully received. Right, okay, B. So we've got x minus 1 over x. Again, think about what happened last time in the last slide about what made that one more complicated. And think about how we dealt with it last time. How can we apply that to this one? Now, the thing that made it tricky last time, I think it's going to make this tricky, is the fact that we've got a fraction over a fraction. So we need to times the top and bottom by something to get rid of the fraction. So we're going to times the top and bottom by x. So times top by x times the bottom by x. And in doing that, if we times the top by x, we're going to get x squared minus 1. That looks familiar. If we times the bottom by x, again, got to times everything on the bottom by x, we're going to get x squared plus x. Now let's try and factorise. So if we factorise x squared minus 1, again, being able to recognise that x squared minus 1 is the difference of two squares. That's going to be x plus 1 over x minus 1. X squared plus x, that's going to be x bracket x plus 1. Now we've got the same on the top as the bottom, so we're going to cancel that out with that one. And we're left with x minus 1 over x. As you're taking notes on this, what I would say is that in your notes, put little asterisks against anything that you're going to need to ask questions on. And then obviously you can leave it as a comment or bring it into class and we can discuss it in lessons. Okay, so now we're getting away from adding and subtracting fractions to multiplying fractions. So we're going to do 1/2 times by 3/5. Now multiplying fractions is dead easy, you just times the top by the top. So that's 1 times 3 on the top and 2 times 5 on the bottom, which is 3 over 10. And then what we do is we see if we can cancel the fraction down, which in this case we can't, because there's nothing that goes into 3 that also goes into 10. So that's part A. Part B, we're going to do exactly the same. So A over B times by C over D. You times the top by the top, so A times C is just AC. Bottom is going to be BD. And there's nothing that's in the top that's also in the bottom, so that's as simple as we can make it. Okay, so this is 3 over 5 times by 5 over 9. Now we're going to go through the way that most people at GCSE and sort of Key Stage 3 attack fractions. Then we're going to sort of have a look at a slightly different way of cancelling it down. So 3 times 5 makes 15. 5 times 9 makes 45. And then I know that 15 goes into both of them, so I can make that 15 goes into 15 once, 15 goes into 45 3 times. So A goes down to a third. However, it's easier, well not necessarily easier in this case, but certainly when we do A-levels, to do any cancelling beforehand. So if we've got 3 over 5 times by 5 over 9, what we're going to do is, the way we got this 15 was by doing 3 times 5. Now, it doesn't matter if we do 3 times 5 or 5 times by 3. So what we can do, in essence, is switch the numerators over. So have 5 over 5 times by 3 over 9. Now, 5 over 5 is a fraction, it's just 1. We're going to write that as 1 over 1. And 3 over 9 is going to be 1 over 3 by cancelling down by 3. So 1 times 1 equals 1, 1 times 3 equals 3. Now you may think that doing it this way is actually easier, but when it comes to doing algebra, it's actually going to be easier doing it this method here. So let's have a look at that. So we've got part B now, which is A over B times by C over A. Let's make my A's look more like A's. Right, so again, what I'm going to do is I'm going to switch the numerators over. I could switch denominators, but I'm going to switch numerators over, so it's going to be C over B times by A over A. So C over B remains a C over B because we can't cancel that one down, but we can simplify A over A as 1 over 1. So C times 1 is C, B times 1 is B. So that just goes to C over B. Now, all that sort of was the basics to sort of try and get you towards this type of question here. So we've got x plus 1 over 2 times by 3 over x squared minus 1. Now this is the third time that this one's come up, x squared minus 1. So what we're going to do is we're going to expand that. So that's going to be x plus 1 over 2 times by 3 over x plus 1 times by x minus 1. So what we can do is we can swap the things over. So we've got 3 over 2 times by x plus 1 over x plus 1 x minus 1. Now if you've got something on the top, you can stick it all in brackets. So we've got x plus 1 on the top and x plus 1 on the bottom. So we can replace, because we've got rid of everything on the top, we replace it with a 1. So now we've got 3 times 1, which is 3 on the top. And then we've got 2 lots of x minus 1. We don't need to simplify that, we don't need to multiply it out. So we can just leave this as the answer. Okay, next question. Division of fractions. So let's have a look at how we do division of fractions normally. And you guys know all about this because when we do 5 6 divided by 1/3, we do the kiss and flip method. So that's 5 6 times by. The divide turns into a kiss, and then the other one flips upside down, so 3 over 1. So 5 times 3 is 15, and 6 times 1 is 6, which cancels down to 5 over 2. Alternatively, of course, when we got to the second one, the multiplying, we could have switched the numerators over, leaving you with 3 over 6 times by 5 over 1, which is 1/2 times by 5 over 1, again leaving us with 5 over 2. So let's see how that works in terms of the algebra. So with part A here, we've got A over B divided by A over C. So we're going to do A over B times by C over A. So then if we swap the tops over, that's going to be C over B times by A over A. A over A cancels, be 1 over 1. So C times 1 is C, B times 1 is B. So we get C over B. Okay, let's do part B. So we've got x plus 2 over x plus 4. And again, let's do the kiss and flip already. So that's going to be times by x squared minus 16 over 3x plus 6. So still with kiss and flip, that bit's done. Now we're going to have a look at factorising. So we can't factorise anything on the first fraction, so that remains as x plus 2 over x plus 4. However, with the next one, we can turn that into, again, it's a difference of 2 squared. x times x makes x squared. 4 times 4 is 16, so we can have x plus 4 times x minus 4. And we can factorise out the 3 from the bottom. So you get 3 lots of x plus 2. So again, let's swap the numerators over. So we've got x plus 4 over, so x plus 4, x minus 4 over x plus 4 times by x plus 2 over 3x plus 2. So let's stick everything in brackets. Now x plus 4 can cancel with x plus 4, and again, if we've cancelled everything, we can leave a 1 on the bottom. Cancel the x plus 2 with the x plus 2, again leaving a 1 on the top. So we're going to end up with, on the top, x minus 4 times by 1, which is just x minus 4, over 1 times 3, which is just 3. So x minus 4 over 3. Next, I've tried to stick the numbers and the algebraic on this one now. So add 1/3 to 3/4. So 1/3 plus 3/4. What we need to do here is we've got different denominators. So we're going to times the top and the bottom by this denominator. So we're going to times the top and the bottom by 4. Now again, we've got to have a common denominator. So we've got to times the top and the bottom by this denominator. So that's going to be times by 3 times by 3. Just let me pause for a second. Okay, we're back in the game. Sorry for the pause there. Right, now the next one. Oh, no, sorry. Follow on with this. So 1 times 4 is going to be 4. And then 3 times 4 is 12. Plus 9 over 12. Now, I know this is just simple adding of fractions, but it's the whole premise of we need to have a common denominator. So we need to multiply the top and the bottom by something to ensure we've got a common denominator. So we've got 13 over 12 here. So if we come on to this question here, we've got a over x plus b. Now this is a really common thing in maths, and this is what a lot of people get wrong, and they tend to drop out marks dead early in C3. You've got a fraction adding to just a regular number. Now we can't do that because we haven't got a common denominator here. So what we do is we write a over x, but we turn b into a fraction. We turn b into b over 1, because anything over 1 is just itself. So what we're going to do is we're going to times top and bottom by x. So we've actually got bx over x. So then we've got a plus b, we've got a plus bx over x. And that's how you simplify that. So let's have a look at this one here. Now this is what a lot of the exams tend to look like. And what I'll do is I'll do another video after this, and we'll have a look at how you solve this and get the marks for it in terms of your C3 exam as well, because this is a common first question. So we've got 3 over x plus 1, and the fact that I've said that, I'd probably highlight that in your notes as well. Say that this is what the common exam questions look like. So we've got 4x over x squared minus 1. Now we know that x squared minus 1 looks like x plus 1, x minus 1, all we should do, because that point has been hammered home loads so far. Now what we've got is we've got a similar denominator, but the one on the right has got an x minus 1, whereas the one on the left hasn't. So what we're going to do is we're going to times top and bottom by x minus 1. And then what we've got is we've got two fractions with a common denominator, so that we can start sorting out the top and simplifying it. So if we simplify that, we've got 3x minus 3 over x plus 1, x minus 1, minus 4x over x plus 1, x minus 1. Now, just be careful with this one. I'm going to come back to it in a second. We do 3x minus 4x, so that's going to be minus 1x. So it's going to be minus 1x, and we've still got minus 3 on the top, over x plus 1, x minus 1. Now in theory we could factorise out a minus here, so minus x plus 3, x plus 1, x minus 1. We can leave it like that. What I would say is, I'm going to put this in a different colour just so it doesn't get confusing. Let's say we had in this one here 3x minus 3 minus 4x minus 6. When we do this, we'd have to do 3x take away 4x to get the minus x, but minus 3 take away minus 6 would be plus 3. So just be careful with that. Okay, so let's have a look at dividing x cubed plus x squared minus 7 by x minus 3. Now this is something that we've done in C2, so it should be reasonably okay. And we're dividing it into x cubed plus x squared. If there's no x's, I'll put plus 0x minus 7. So what do you multiply this by to get x cubed? That's going to be x squared. So you're going to get x cubed minus 3x squared. We then do the top, take away the bottom. So x cubed take away x cubed goes. X squared take away minus. So take away minus is a plus. That's going to be 4x squared. Then we bring the other bits down. So plus 0x minus 7. Now what do we multiply x by to get x squared? So 4x squared, we multiply it by 4x. So times everything then by 4x, that's going to be 4x squared minus 12x. And then we subtract the top from the bottom. So 4x squared minus 4x squared goes 0x, again 0, take away minus, it's going to be plus 12x minus 7. And then what we're going to do is we're going to see what you multiply x by to get 12x. That's going to be plus 12. So multiply everything then by 12. So that's going to be 12x minus 36. And we do the top, take away the bottom. So 12x take away 12x goes. And minus 7 take away minus 36. Again, take away minus. It's going to be minus 7 plus 36, which is going to be 29. Which means that we've got a remainder of 29. So when we do this, we can write that x cubed plus x squared minus 7 divided by x minus 3 equals, and we've got our answer here, which is x squared plus 4x plus 12 plus a remainder of 29. And when we write our remainder, we write what it was being divided by, so x minus 3. Again, that's an important thing to do, so make sure you've got that written down and highlighted in your notes. We do our answer, which was this one here, plus our remainder, which was 29, over x minus 3. Okay, so there is another way to do it if you're not going to use long division. It's the remainder theorem, which I'm not sure if I've got next slide. Yes, I have, so I'll do it on the next slide. Okay, so we've got x cubed plus x squared minus 7, and that equals x minus 3 times by something. So in order to get the x cubed, we're going to have something x squared plus something x, so plus bx plus c, and plus we're going to have a remainder. So we're going to write that as d. In fact, we can just write that as plus d. Okay, so what do you multiply x by to get x cubed? So that's just going to be a regular x squared. So a is going to equal 1. And if we're going to use the remainder theorem, using the remainder theorem. Now the remainder theorem, if we're dividing by x minus 3, we need to substitute in x equals 3. That's what the remainder theorem is. So we substitute in x equals 3, and see what we get as the remainder. So we're going to have 3 cubed plus 3 squared minus 7. So 3 cubed plus 3 squared minus 7, and obviously that equals 29. So our remainder is 29, so we've got our plus 29 on the end. Now, we know that x times ax squared equals 1x cubed, so that equals that. We know that if we then find out what's the value of b is, so if we know that, let's have a look at this. No, let's go for the value of c first of all. Now the way we get minus 7, again this seems more complicated than it is. It sort of makes sense once you've done it a couple of times. So to get this minus 7 on the end, we do minus 3 times c, and then we're going to add on our plus d. So if we do that, we're going to get minus 3c, then we're going to add on our remainder, plus 29, and that equals minus 7. So if we take away 29 from both sides, we get minus 3c equals minus 36. Divide by minus 3, we've got c equals 12. Okay, the next one is we've got to work out what this value of b is for the x's. So we've got to get 1x squared, or we've got to get plus 0x's. So let's see how we get the x squareds. So the way we get x squared is we do the minus 3 times by ax squared, so that's going to be minus 3ax squared. And if we do x times bx, that's going to be plus bx squared, and that has to equal 1x squared, because we've got 1x squared in the answer. So again, just the thing that we're doing is we're doing this bracket times by this bracket equals this thing here. So the way we get our x squared is we do x times bx to get bx squared, and we do minus 3 times ax squared to get minus 3x squared. Now we know that that should equal 1x squared, or just x squared. So we already know that a is 1. So we can say that we've got minus 3x squared plus bx squared equals 1x squared. So therefore, b must equal 4, because minus 3 plus 4 equals 1. So we've got b as 4, so we've got plus 4x. And that's it. And to see whether or not you have got the correct answer, we can then multiply out our answer, and we should get this thing here. And again, if we have a look at our previous answer, we've got x squared plus 4x plus 12. So it's another way of doing it. And what we've got to do, I know it's not easy to start off with, but that's what we're going to be doing in class. We're going to be practicing this. We've got to be able to be comfortable getting both of these. Incidentally, this second method we need to be able to use properly in the first section of C4 as well. Okay, so we've got one more to do. So we're going to divide x power 4 plus x cubed plus x minus 10 by this thing here. Just let me pause for a second. Okay, so I've just got my next class to wait outside whilst I finish doing this video for you guys. How good am I? I'm not great at my job, but that's by the by. Okay, so we can do x to the power of 2 plus 2x minus 3, and we're dividing that into x power 4 plus x cubed plus 0x squared plus x plus 0. So what do we multiply x squared by to get x power 4? We need to multiply by x squared. So we're now going to multiply everything by x squared. So x squared times x squared is x to the power of 4. X squared times plus 2x is going to be plus 2x cubed times x squared by minus 3, and we get minus 3x squared. We're then going to do the top line, take away the bottom line. So x power of 4 take away x power of 4, that goes. X cubed take away 2x cubed is going to be minus x cubed. 0 take away minus 3x squared is going to be plus 3x squared. What do we now multiply? and then, sorry, we bring everything else down. So plus x plus 0. What do we multiply x squared by to get plus... sorry, what do we multiply x squared by to get minus x cubed? We multiply by minus x. So multiply everything by minus x, and we're going to get minus x cubed plus, sorry, minus sorry about that, x squared minus 2x squared plus 3x. Sorry, that was x cubed there. So top line take away the bottom line. The first one goes 3x squared take away minus 2x squared is 5x squared. X take away 3x is going to be minus 2x, and then plus 0. What we're then going to do is we see what we multiply x squared by to get 5x squared. That's going to be 5. So we then multiply everything here again by 5x squared. Again, nothing new here. 5x squared plus 10x minus 15. So top take away the bottom is going to be 0. 2 minus 2x take away 10x is going to be minus 12x. 0 take away minus 15 is going to be plus 15. So this here, because we can't multiply x squared by anything to get to minus 12x, this is going to be our remainder. So the answer is going to be x squared minus x plus 5 plus a remainder of minus 12x plus 15 over what we're dividing by, which is x squared plus 2x minus 3. And again, what we could probably do is we could factorize our remainder plus, so if we take out the 3, if we take out minus 3, we're going to get 4x minus 5 over x plus 3, x minus 1, and that'll be that. Okay, can we do this another way though? And the answer is yes, but I'm going to need to pause and get my class in. Bear with me. Okay, so just also very quick, I've just made an error. This was minus 10 here, so I should put down a minus 10 right there. And so the way that transcribes, so that should be minus 10 there. Then if we do minus 10 take away minus 15, that should be plus 5 there, which means that we've got 12x plus 5 over here. Which means that we can't do any of the simplification there, so the answer is simply that there. Of course, you can still factorize the bottom here if you wish. Now, we can either do it this way, or we can do it the other way, where we have a look at the remainder theorem. Except we don't look at remainders this time, but we do have a look at the multiplication stuff. So, let's have a look at how we do it, because again, we need to be familiar with both methods. We've got x power 4 plus x cubed plus x minus 10, and that equals x squared plus 2x minus 3 times by something x squared plus something x plus something plus our remainder. Now this time the remainder, because we're dividing by x squared, we do one less than the power, so our remainder will be plus something x plus something. And all we do is we do exactly the same as we did before. So this times this makes x to the power of 4. So therefore a must equal 1. It's got to be 1x squared. So that's going to be 1x squared. And then if we have a look at the x cubed, the way we do x cubed is we do x squared times that. So that's going to be bx cubed. And if we do 2x times ax squared, and we know that a is 1, that's going to be plus 2x cubed. And we can see that's got to equal 1x cubed. So therefore, b must equal minus 1, because you've got to have minus 1x cubed plus 2x cubed to make 1x cubed. So that's going to be minus x. And then what we're going to do is we're going to have a look at the x squareds. So to make an x squared, we have a look at the x squared times c, so that's going to be cx squared plus this one. So that's going to be 2x times bx, and we know that b is minus 1. So 2x times that is going to be minus 2x squared. That has to equal 0x squared. So, oh no, sorry, my mistake. To make the x squared, let's go through that again, sorry, it's my mistake. We've got minus 3 times ax squared. So it's going to be minus 3x squared. 2x times minus 1 is minus 2x squared. If we have a look here, there's no x squared there, so that's got to equal, oh, sorry, I've made a mistake again. Right, let's go through it one more time, my apologies. Sorry, yes, so to get the x squareds, we can do x squared times a c, so that's going to be cx squared. We can do 2x times a minus 1x, which is going to be minus 2x squared. And then the minus 3 times that one, and we know that a is 1. So that's going to be minus 3x squared. And as we have a look over here, there's going to be 0x squareds. So that's going to be cx squared minus 5x squared. And that equals 0x squared. So therefore c equals 5, which matches what we had over here. So now we need to get the dx and the e. So the way we do that is we're going to have a look at the x. Now the x's need to add up to 1x. So the way we get x's is we do the minus 3 times the minus x, that's going to be plus 3x. We're going to do the 2x times a 5, so that's going to be plus 10x. And plus our dx on the outside, and we know that has to equal plus 1x. Oh. So equals, not sure what's happened there. Okay. Equals 1x. So it's going to be 13x plus dx equals 1x. So therefore d must equal minus 12, which again is what it does over here. So it's going to be minus 12x. Then plus e. The e is going to be the number on the end. Now we know the number has to equal minus 10. So the way we get the number on the end is we do this minus 3 times a 5, so that's minus 15. Then minus 15 plus our e, that equals minus 10. So therefore e must equal 5, which is what we've got over here. So again, that's two methods of getting the same answer. Okay, what I need to do is make sure you've got all those notes written up, and if you bring them to class on Wednesday, we'll go through the exercises. What I'll also do in the next video is I'll do an exam question looking at a couple of these topics. Okay, thank you very much.